Welcome. New week, same great thing. All right. We're going to start systems of equations today. So, big deal, right? Systems of equations is usually something that gets students really, really messed up. I'm fixing that because my desk is totally weird here. Anyway, okay. A system of equations is two or more equations with two or more variables in each equation. You're going to see a couple of examples of this today. We're going to spend, I would say, about a week and a half or so on systems completely. If you had it last year, awesome. If you don't freak out. It's actually not that bad. And it's a nice logical step after we did slope from a couple days ago. So, a system of equations. We've already discussed what it is. Now let's just get into it. There are three ways to solve a system of equations, at least the three I'm going to tell you now. The first one we're going to work on is the graphing method. I like this one because it's very, very visual. It's easy to represent. So I've got two equations here, and I hope that you can see them. I probably really can't, though. So the first equation is y equals 3x plus 2, right? And it's in slope-intercept form, so it's a good thing we did slope and slope-intercept. And then the other one is y equals negative 2x minus 3. The graphing method is very simply this. Before we do that, I'm trying to solve for x and y. And I can because there's two equations. Okay, we're going to put these together. So we're going to graph the first equation, right? First thing I have to do is go to the y-intercept, which is 2. So I'm going to go to 2, I'm going to make a point. Okay? Now, the slope is 3, which means I'm going to go up 3 over 1, right? Don't forget the over 1, because that is a fraction where it's over 1. So from this point, I'm going to go up 3, 1, 2, 3, and over 1. Now, to keep this nice and even and everything like that, I'm going to just keep doing the slope instead of making some really terrible line. 1, 2, 3, 1. 1, 2, 3, 1. Okay. Now, in another color, right, I'm going to use probably here, I don't know, red. Let's go ahead and graph this line. I'm going to just circle this with red. Now, I'm going to go from the origin down 3. So it's going to be 1, 2, 3. And the slope is negative 2, so down 2 over 1, right? And remember, the negative sign belongs to the numerator. So down 2 over 1. Down 2 over 1. Now, if I were to draw these lines, which I'm not going to, I'm just going to keep using dots, you'd see that they would cross somewhere over here. So down 2 over 1, the opposite of that is up 2, left 1. So up 2, left 1. Up 2, left 1. Okay. Now, for the blue line, the black line, that was up 3 over 1, so it's going to be down 3, left 1. 1, 2, 3, left 1. Now, here is what's interesting. Both points will go on that ordered pair, right? They're going to cross at that section, and now I can kind of draw a silly little line here. So that's the line, the black line, y equals 3x plus 2, and the red line is going to be y equals negative 2x minus 3. The point at which they cross is the answer. The ordered pair is the answer. Okay, so that's going to be kind of weird to think about, right? But the ordered pair is this. So the ordered pair is negative 1, comma, negative 1. That's my answer. Now, let's think about this for a second. This is an x value, this is a y value, right? Well, if I plug these into the equation, both of them, they would both work. So let's go ahead and try that. Right? So y is negative 1 equals 3 times negative 1. They just both happen to be negative 1 plus 2. So 3 times negative 1 is negative 3 plus 2 is negative 1. That's a true statement. This is a true statement, which means that is just guaranteed, or we just double-checked it to be the answer. So that's a system of equations. It is two equations. I'm going to graph both of them, and then I'm going to find the point at which they both intersect. Now, a little bit of advanced, if we go a different route, and I give you two different equations, think about what happens if they never cross. What are they? You know, what kind of characteristics do they show? And what if you draw one line, and then you draw another line, but it's the same line? Think about what the solutions will be to that, and we'll talk about that more in class. So, system of equations. Please replay this video, because systems is a big deal. We're going to spend a good amount of time on it. In fact, after it, we're probably going to test. So, go ahead and replay me, pause me, make sure you've got this down, and make sure you for sure know how to graph. All right, see you later. Bye-bye.